Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we impress weird and wonderful science directly onto your brain. I'm Ian Woolf. On this retro edition from the 2007 archives, fly me to the moon with fireworks and gecko technology. In 2007, there was suddenly a new race to the moon. I investigated who's going, and perhaps why. After 35 years of neglect, suddenly everybody wants to go to the moon. NASA celebrated the 35th anniversary of Apollo's last landing by announcing that their planned return in 2020 is on track, despite budget cuts. China is not only planning on going to the moon, but they're going to use private capital to get a robot there by 2012 and to land people by 2027. Russia will also land a robot in 2012. Going to the moon is no longer a game that only the governments of nation-states can afford to play. Google is offering $20 million to the first privately funded organisation that sends pictures back from the moon, before China and Russia do so in 2012. There's an extra $5 million prize for extra achievers. Extra achievements might be roving further than 5 kilometres, capturing images of man-made objects on the moon, or surviving a lunar night. There's also a $5 million second prize to keep the competition interesting. Google and the X Prize Foundation hope that from the experience of competing to travel to the moon, society will learn the techniques to shield astronauts from radiation, beam power to enable fast transportation in the solar system, build large astronomical tools to learn much more about the universe, and protect the Earth from the threat of impacts from asteroids and comets. Very worthy goals. The Google Lunar X Prize was inspired by the Ansari X Prize. This was a space competition in which the X Prize Foundation offered a $10 million prize for the first non-government organisation to launch a reusable manned spacecraft into space, twice within 2 weeks. The aim was to inspire the development of low-cost spaceflight. The prize was won in 2004 by the experimental spaceplane Spaceship One and was financed by Microsoft co-founder Paul Allen. $10 million was awarded to the winner, but more than $100 million was invested in new technologies in pursuit of the shiny, shiny prize. A company called Odyssey Moon on the Isle of Man in the Irish Sea is the first entrant in the Google Lunar X Prize. Next was Carnegie Mellon University and the Microspace Corporation. The company Aplios are competing with open source software and hardware. Over 100 groups have registered interest in entering the competition. So why the sudden interest in returning to the moon? Is there any oil there? Well, almost. There's a clean, green, non-radioactive fuel called helium-3 on the moon that has the potential to replace oil and coal and uranium. Experimental nuclear fusion reactors have turned helium-3 into helium-4 and a whole lot of energy, but with no pollution. Well, that is, other than what you generate by going to the moon, mining it, and bringing it back. Helium-3 is very rare on the Earth, but very common on the moon and the rest of the solar system. It was deposited on the moon over billions of years of exposure to the particles blown off the sun while it burns. Sort of like smoke from the solar furnace. The Earth has been shielded from most of it by our atmosphere. 20 tonnes could fuel the population of the USA for a year, which makes it worth about $4 billion a tonne. There are thousands of years' worth of helium-3 on the moon. Of course, even if we were suddenly to get all of this wonder fuel back home, we don't actually have any helium-3 power generators to feed it to. The technology doesn't exist yet. When the technology does exist, political power could easily come with the electrical power it offers. If that's the case, then we wouldn't want just one government or corporation controlling access to space. Of course, this raises the question of who owns the resources of the moon. Is it Terra Nullius, the first to stake a claim to get the gold? Well, no. There's the UN Outer Space Treaty of 1966, Resolution 2222-XX1, which says that no nation can claim sovereignty over anything off the Earth, and that resources must be used for all mankind
not just for one nation. Of course, 3 NASA engineers quietly found a loophole, allowing them to control almost all of the moon as individuals. Dr. Joseph Resnick, Dr. Timothy R. O'Neill, and Guy Kramer, who together form the ROC, Resnick-O'Neill-Kramer team, have acquired the mineral rights for 95% of the side of the moon that faces Earth, the polar regions, and 50% of the far side of the moon. They did this by finding the loophole and submitting their claim to the World Court at The Hague and to the United Nations. In 25 years, no one has ever disputed their claims for ownership. They've generally set aside 20% for historical conservation of the Apollo 11 landing site and claim the last 75% as their own mineral rights. You'll be very pleased to hear that they're concerned about how ugly the moon will look while it's being strip mined. So they want to enforce what they call visual mitigation, so that strip mining in your sky is less obvious. 700 million acres of Mars and 8 other regions have been designated as the first extraterrestrial nature preserves. So they've been set aside to preserve things for the public. Dr. Resnick has structured the Universal Mineral Leases Registry so that anybody can apply to him and his ROC group for mineral rights on the moon. While the replacement for oil might plausibly be the motivation for the US, China and Russia, it's unlikely to matter at all to the people entering the Google Lunar X Prize. There's a wonder and majesty to space travel that nothing else can match. Communication satellites and Google Earth are barely scratching the benefits society has gained from NASA's bold steps.
Of course, things didn't go as planned for the Google Lunar X Prize, and nobody won the $30 million. They changed the rules and awarded nearly $6 million in terrestrial milestone prizes for ground testing of imaging, landing and mobility technologies in 2015. They awarded a $1 million moonshot award to the Israeli company SpaceIL that crashed their Bereshit spacecraft on the moon instead of the hoped-for soft landing in 2019, when the spacecraft experienced main engine failure and lost communication with mission control in Tel Aviv. The planned Russian robot landing on the moon for 2012 got delayed and still hasn't happened. And of course, NASA didn't return to the moon in 2020 as originally planned either. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
And here's Patrick Rubie with the science behind fireworks.
It's that time of the year again. Some of us are still reeling from the indulgences of the festive season. We gather around with our friends or family, crack open a bottle of bubbly, and turn our eyes to our TV sets, or to the skies if we're outside to watch the fireworks. Others might prefer not to get involved with the New Year's furore of loud noises and bright lights. After all, the use of fireworks is a contentious topic. So what impact do they have on our lives and our environment? Is it a good one or a bad one? Fireworks have been around for a very long time. The Chinese were using them at least as far back as the 12th century AD. They were an extension of the development of gunpowder and were primarily used to frighten off bad spirits and to pray for happiness and prosperity. They gradually spread to the West and were used in celebrations and festivals such as births, deaths, weddings, coronations, and to welcome the new year, something we still use them for today. Some of the other major events that they are used for in the world today include Guy Fawkes Night on the 5th of November in the UK, the Edinburgh Arts Festival in September, Thrissur Puram and the Festival of Lights in India, Independence Day on the 4th of July in the US, Chinese New Year around the world, and various other festivals in Asia, Europe and North America. So what are the fireworks made of? How do they give off their bright and beautiful colours and loud bangs? Fireworks, or pyrotechnics, basically consist of a fuel which allows it to burn, an oxidizer which produces oxygen for the combustion of the fuel, colour-producing chemicals, a binder to hold it all together, and sometimes a chlorine donor, which provides chlorine to strengthen the colour of the flame. If you can remember your high school chemistry, you might recall that certain metals produce different coloured flames when you held them over the old Bunsen burner. Well, the principle is the same in pyrotechnics. Different metal compounds produce different colours. Strontium and lithium compounds are red, calcium is orange, sodium is yellow, barium is green, copper halides are blue, potassium is purple, iron is gold, and aluminium or magnesium are white. Sometimes the metals themselves can be combined in an alloy if this works better, such as magnesium and aluminium to produce magnesium. The types of pyrotechnics produced by these bright chemicals are quite astounding. You have a basic star shape, found in a lot of different types of firework, named after flowers or trees. A crosset firework has large stars that break up into smaller ones. A Roman candle, made of several large stars firing intermittently in crisscrossing shapes. Skyrockets, Catherine wheels, and the salute, which is usually left till the end of a display and is a firework with a quick flash and a loud bang. So fireworks are a very bright and loud way of celebrating. Perhaps a source of good fun for family and friends, but what about our environment? There is some carbon dioxide given off from fireworks, but the components that are released as carbon dioxide come from wood. So you could make an argument that this is more likely to be carbon neutral. In some estimates, carbon dioxide released from fireworks has been put as accounting for about 0.03% of total carbon dioxide released into our atmosphere, which is much less than that produced by fossil fuels. The metal compounds that produce the bright colours, some of us adore, can be a problem though. Some of them are toxic, both to us and to our environment. For people with asthma or allergic sensitivities, they could be a bad thing. If they get into our waterways, they might be harmful to fish and marine life. However, this is difficult to prove because heavy metal compounds are also produced by power plants and can find their way into our waterways too, so we can't really be sure where the compounds are coming from. The noise and bright light produced by the fireworks could be damaging for wildlife and pets. It could scare animals from the vicinity of fireworks and drive them onto roads and into oncoming cars. But is it really such a problem for wildlife to have the occasional firework display? I talked to our panel of science reporters at the Diffusion studio to see what they thought. So in Australia now, it's legal in Tasmania to buy fireworks, low-level fireworks. They're called Type 1 fireworks. I'm not exactly sure what that means. And in the ACT and the Northern Territory, it's legal to buy fireworks. I think it's for up to 1 week before the Queen's birthday in the ACT, and Northern Territory Day, which is the 1st of July in the Northern Territory. I just wanted to see, what do you guys think of fireworks? I remember when I was a little kid, I was about 6 years old, we used to set them off in our backyard, and we had a cat back then, and the cat would usually run away screeching because it hated the noise. I mean, has anyone had any similar experiences with pets or stuff like that with fireworks?
We always put our pets indoors when fireworks were going to go off so that it wasn't a problem.
But what happens if your pet escapes?
Then you've done the wrong thing.
I certainly do have a lot of sympathy with pets being frightened, but I'm also rather afraid of young boys having some wonderful ideas that they can repackage fireworks, and that happens all too often, and there's a lot of damage done from that. Or just improper use of, say, rockets to parties, where Dad might want to launch a rocket and in the process has fueled himself up with amber fluid and fires the rocket directly at himself or one of the family and does them quite a bit of damage, and that can be a really serious problem as well.
Because it was accidents like that which prompted the ban all those years ago, wasn't it?
There were two stages of the ban. As I've read, first they banned the explosive fireworks, the ones that just went bang, because they used to sell stuff that just went bang, along with all the pretty things. So you could just buy pretty ones and not things that went bang. And then later on they banned everything and you needed a license because people, well, they still managed to find ways to hurt themselves even with the pretty ones. Because if you tape them up, they still go bang.
Is that a bit like the fizzing you can make with matches when you wrap them in foil first?
Exactly. You're confining the combustion gases, and that's what causes the explosion. So people found ways, and some people could handle it, and some people thought they could and then hurt themselves or other people. So now you need a license.
What do you think of the idea of making fireworks a bit greener? I know about 3 years ago in the US, for Disneyland, they started to introduce something called a compressed air firework. So they replaced the gunpowder with compressed air. and they use that to provide the fuel or the power for the fireworks to be projected, and they claim that that actually produces less harmful waste, but also it reduces the noise.
So how does it light up if it's not on fire?
Now, my understanding of that is that they were using compressed air as the replacement for one of the components, but not all.
Yeah.
So typically, for example, if you have a shell, an aerial shell, which is basically a small one, might be a sphere of the pyrotechnic material, say 5 inches or 12.5 centimetres across, then you've got to get that up to a certain height. And typically the way they do that is they use an explosive charge, a slow-burning explosive charge, which they then use as a kind of projector, if you like, which shoots the bomb up to height. And my guess is that they probably replaced that gun, if you like, with a compressed air gun, which would save on the explosive charge.
And I think
the lifting charge, if you like.
You've just hit the key words that are the other reason for why the ban will stay on despite any attempts to lift it for the general public to use fireworks. Use the words bomb and gun. And the fact is, fireworks could be used as weapons or be mistaken for weapons by people who are trying to protect us from criminals who use big weapons, and therefore it's not safe for people. It's just like replica guns aren't really a wise thing for kids to play with if they're realistic, because someone might think they're a real gun and a policeman might try to disarm them by shooting them, which has happened in the US.
Has anybody else here had any other sort of more sort of personal experiences or experiences with their family with fireworks other than Dad setting off a couple in the backyard?
My great-grandfather used to own a factory in China.
A fireworks factory?
Yeah, a fireworks factory.
Wow.
He actually helped set up the fireworks for the opening of the Sydney Harbour Bridge. My mum told me bits and pieces of the story. Like, she said that my grandpa was in a partnership with 4 of his other brothers, and they came to Australia to set up the fireworks in Australia because that time China was the best place to produce fireworks.
It's also a bit of an art. I went to a fireworks competition in Montreal a few years ago, and really what they do for the Sydney Harbour New Year's fireworks are really crude, simple things. You can do fantastic artworks in the sky if you know what you're doing. I saw them draw maple leaves in the sky and just, actually construct images in the sky with the fireworks. So I think if they're going to spend huge amounts of money, they should do it right.
For the 2000 Olympics, I performed in the opening and the closing ceremonies, and one of the things to try and convince people that I should perform on main stage was I needed to have some sort of street cred, and so I got a pyro licence. So clearly if I was going to do fire breathing on main stage, then having a pyro licence sort of looked impressive. You
did fire breathing on the main stage?
Yeah, sure.
Oh, wow.
And did the closing ceremony as well. It was quite a buzz. It was a huge audience, 120,000 people or something like that. And we were pretty well prepared. And one of the things about performing in front of a group that size is you don't get sort of the nerves that you get when you're performing, say, in front of a few thousand people. You just walk out there and the audience is a long distance away from you, so you don't get the sort of personal feedback and the nerve issues that you get in a smaller group. What they didn't warn us of was the fact that as we came out, the whole place would light up with a terrific pyro display, and everyone had those flashing armbands and torches. We came on, blew our first flame, and the whole place erupted. It was just a most amazing feeling where everyone was flashing their torches and waving their hands, and there were flashing LEDs all over the place. There was 120,000 people, and we were, of course, broadcasting to 4 billion people worldwide as well. It was quite an experience.
What did it take to get a licence for the Sydney Olympics as a pyro?
Well, no, I didn't actually have it as a pyro for the Olympics. What I had was an indoor licence, if you like, the ability to detonate things safely. That's not one to be a practitioner at the Olympics.
So maybe an explosives licence for children is what we need.
I think actually there's probably difficulties with that.
Really?
I wouldn't. Yeah, I wouldn't encourage a lot of people to go out and get it. And the other thing is, I'm almost certain that the rules will have changed since then because of the 2001 New York issue.
Okay, so the answer is to lock up your pets and get a license in the future.
Education is the solution.
Education is the key.
Scientific education, indeed.
And that was our panel discussion on the impact of fireworks. What do you think?
Ever wondered what geckos have in common with the art of spring cleaning? Celine Steinfeld is about to explain how these small lizards can add a little extra sheen to your family home.
The link between geckos and cleaning lies within a type of cleaning cloth called a microfibre cloth. Microfibre cloths have recently become readily available in supermarkets and other retailers. They can be used for cleaning surfaces, car detailing, and even for drying after a shower. You don't even need chemicals with your microfibre. Just a splash of water or even a dry microfibre cloth will do the trick. On the supermarket shelf, they look like any other ordinary colourful cleaning cloth. So how are these cloths different to your standard kitchen rag? Are microfibre cleaning cloths the ultimate chemical-free solution? Or are they just a gimmick, demanding extraordinary amounts of elbow grease? The solution is drawn from US researchers at the University of California, Clark College and Stanford University. A few years ago, one of the researchers watched a gecko walk across the ceiling of a hotel room in Hawaii. How do these creatures manage to defy gravity and stick on the ceiling? Geckos have been the subject of scientific study for thousands of years. Originally, some scientists thought that geckos might make a kind of glue to coat their five-toed feet, just like insects that can stick to waxy leaves. But geckos don't leave sticky tracks. The theory that geckos have suction cups on their feet was disproved in 1939. Not even water on a surface would affect a gecko's stickiness. A few years ago, researchers used a special microscope to reveal millions of microscopic hairs on the bottom of geckos' feet. Each of these hairs, known as setae, is split into billions of nanoscale bristles. However, these individual hairs aren't sticky. They only become sticky en masse when the gecko is in action scurrying across the ceiling or hanging single-toed from sheer walls. When the gecko hairs get intimately close with the surface, they create a powerful bond that is 1,000 times stronger than the force that geckos need to hang onto a wall. These forces are caused by temporary changes in the electric fields of atoms, known as van der Waals forces. A gecko can control its adhesion, sticking really, really well, or detaching readily as many as 15 times per second. So back to microfibre cloths. The structures are inspired by these nanoscale bristles on the pads of geckos' feet. The exceptionally soft microfibre cloths are made up of over 1,000 strands of non-abrasive polyester, polyamide or nylon. Each strand is up to 200 times finer than a human hair. The tiny wedge-shaped strings act like a miniature razor that cleans and scrapes the surface dirt, dust and oils. So it's simply the geometrical shape of the material that holds particles in the open spaces between the fibres with friction. Regular cleaning cloths, however, don't actually have as much surface area or space between the fibres, so the friction's much lower. These cloths will tend to push around the dirt and leave residues rather than collect it. It's easy to emulsify the particles in the microfibre cloth because you can wash it with mild soap or detergent. The microfibre cloths not only trap and retain dirt, they eliminate the need for using a concoction of chemicals like window cleaners and all-purpose sprays that can be toxic to you and your environment. Microfibre cloths will last a long time. However, be aware that they're actually made from a non-renewable plastic and will not break down in the environment. The stickiness of geckos' feet can not only add a little sparkle to your home, but with a little further research, microfibre may have some potentially exciting applications. High friction and low adhesion are desirable traits for products such as life-saving gloves for mountain climbers, medical tape to hold tissue together after surgery, and cars that can be parked vertically on a brick wall. Until then, use a microfibre cloth for cleaning and stick to the comfort of your own home.
And that was Celine Steinfeld reporting.
Contributing to this edition were Celine Steinfeld, Patrick Rubie, Charles Willock, Joanne Chang and Lara Davis. You can see all the Zoom videos from 2020 on the Diffusion YouTube channel. Subscribe and like to youtube.com/c/Diffusion Radio. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 MVR in Nambucca Valley, 3 MVR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's science360.gov internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Make a donation through paypal.me/IanWolf or join my patrons at patreon.com/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next year on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.